Hey guys, today in this video I'm going to show you something a little from the projectors that we've been doing. Yes, this is still a physics lesson but also kind of a math lesson. So we have already heard of the formula S equals UT plus half AT squared, right? Now today I'm going to teach you how we came to this formula, so basically the derivation of this formula. So right here we have a velocity time graph. And this is a very simple velocity time graph that I've drawn. We have velocity here and there, time. So now what we know is that in a velocity time graph, the distance is the area under the graph. So the distance, if I drew a line like this, the distance would be this area in this shape. Now we can directly measure this area by using the parallelogram rule or trapezium rule. Yes, that's it. But I'm going to show you a much easier method. So first let's work with this equation. Yeah, if I rearrange this equation, I can write v minus u equals at. This is very simple. I hope I don't need to explain this to any one of you guys. I just rearrange this equation and I got this. Now we're back, and so as I was saying, this is the area under the graph, and I just changed this to v minus u equals at. So this point right here, as I was saying, is our initial velocity u, and this right here, if I draw a straight line, more or less straight, like above here, this would be our v, final velocity. Okay, let's write this as velocity and time. Yeah, so we have our initial velocity and final velocity. Now this distance, okay, is equal to, if we divide this by this distance, right? So this and this are the same. So we can also say this is v, this is u. Yeah. Now v minus u is the length over here, so I can write it as at right here. Yes, because I have this v minus u equals at. Now when I said I'd make this simpler, by that I just basically mean instead of using the trapezium method, I'd just divide this into a triangle and a rectangle. That would make it easier. I'll find the area of a triangle, find the area of a rectangle, and add them up. Simple. So instead of so we did this. We wrote at instead of v minus u. And now another thing about this equation is, like, as you can see, this equation does not have the value v in it. Final velocity is not in this equation. And there's the main purpose of the equation. So if there is something that doesn't, if there is, let's say, a question that doesn't have final velocity in it, then we'd have to use this. Let's say there's a question where they say find the distance, this is our initial speed, this is our acceleration, and within this time find the distance. Yeah, well, we don't have initial velocity, so we're using this. So the main idea of me doing this at is to cut v out of the equation, right? So area of triangle, let's put it, area of triangle is a into b into half, right? Okay, so I'll write s equals, we'll leave some space over here, okay, and I'll just write it as half into, this is at, and into, we have the time over here, from here to here is the same as here to here, times time, right? We have that part. Now there's obviously a plus here because this is the area of the triangle plus the area of the rectangle. That will give us the final value. Area of rectangle, very, very simple. From here to here is u, or u minus 0, it's still u. So this distance is u. We have time here, so I just put ut. That's simple. And I just add them all up. ut plus half at squared. It's that simple. The derivation of this method is that simple. It's crazy how this formula has been used in so many places, and yet we didn't know how the derivation came from, where the derivation came from. This formula can be used in the most obnoxious, crazy questions, and still the derivation of this is that simple. And yes, this is all the video there is to it. I just wanted to make a really, really quick short video for you guys. Thank you for watching, and hopefully this isn't that confusing. If this is so confusing, I don't mean to be mean, but you must go back to 5th grade.